Alright, so we're not going to do this one because it is a double angle. But and that's in your next little unit. But let's keep going. So tan squared plus 1 is equal to 1 over cosine squared. So if you look at our stuff here, we've got 1 plus tan squared is equal to secant squared. Alright, so that's this part can be rewritten. So 1 plus tan squared equals secant squared. Now we know that secant is 1 over cosine. So therefore secant squared is equal to 1 over cosine squared, which is what we are looking for. So good on that one. Now 1 minus cosine squared is equal to sine times cosine times tangent. So we know that, so we know we got sine. I'm gonna substitute our what we know for tan to be, which is sine over cosine. So we got sine times cosine times sine over cosine. The cosines are going to cancel out, right? So then we're with sine times sine, so sine squared. Now, if you remember our Pythagorean identity here, it tells us that sine squared plus cosine squared equals 1. Now, if you solve this for sine squared, then we are left with sine squared is equal to 1 minus cosine squared. So we have sine squared on the right. We want 1 minus cosine squared on the left. Sine squared is 1 minus cosine squared because we just talked about that. So that checks out. Now we have cosine squared times tan squared is equal to sine squared. Another one that goes back to the what is tan. So we got cosine times, or I guess cosine squared, sine squared over cosine squared. You cross those out and we're just left with sine squared. Alright, so 1 over cosine squared, 1 over cosine is equal to sine times tangent plus cosine. So if we look at this left side here, let's see what we got. So we got sine squared over cosine, right? Because tangent is sine over cosine. So multiply that, we got sine squared over cosine plus cosine is equal to 1 over cosine. Now, in order to solve this one, we have to have, or in order to add these together, we have to have like denominators. So I'm going to multiply the second part by cosine over cosine, and that's going to be equal to sine squared plus cosine squared all over cosine. Now, Pythagorean identity tells us sine squared plus cosine squared equals 1. So then this means that we have 1 over cosine. Sorry, that was my dog. Alright, so we have tan squared is equal to tan squared over sine squared minus 1. So let's take a look at this. We got tan squared is equal to, so we have sine squared pancake. So we have sine squared over cosine squared times, so remember when we're dividing like this, we could do a times 1 over sine squared. So with this, we can cancel these out. So we have 1 over cosine squared minus 1. 1 over cosine squared can be changed to secant squared. So we've got secant squared minus 1 is equal to tangent squared. And because of our identities up here, we know that 1 plus tan squared is equal to secant squared. Solve for tan, we would have secant squared minus 1. So this checks out. So we have cosine squared times 1 plus tan squared. So if we were to when we have this out here, that makes it seem like it was factored out, right? So now we're looking at cosine squared plus cosine squared times sine squared over cosine squared. Now these will cancel out, so then now you're just left with cosine squared plus sine squared equals 1. Pythagorean identity tells us that cosine squared plus sine squared is 1, so 1 equals 1. This checks out. 1 over cosine squared equals tan squared plus 1. This is easy. We're just back with 1 over cosine squared is equal to the secant squared. So we have secant squared is equal to tan squared plus 1. This is a double angle. You'll get into that in the next little bit. 1 plus cosine squared. This is double angle. So now you have tan squared minus tan squared minus sine squared is equal to tan squared times sine squared. So tan squared, you are going to have sine over cosine, or sine squared over cosine squared, minus sine squared. You need common, in order to subtract these, you need common denominator, so multiply this and we're going to have sine squared minus sine cosine over cosine squared, and you have factor out the sine on top. So sine squared times 1 minus cosine squared all over cosine squared. Now sine squared over cosine squared becomes tangent 1 minus cosine squared. If you remember our Pythagorean identity, which tells us cosine squared plus sine squared equals 1, if you solve for sine there, you're going to get 1 minus cosine squared equals sine. So then we have tan squared times sine squared. This can be our answer. Alright, so that checks out. So we have sine times 1 plus tan is equal to tan times sine plus cosine. So if you did this, you would have sine times secant. So then you have sine over cosine, basically. Right, because if you have secant... Oh wait, no, that's 1 plus tan squared. My apologies there. Alright. So sine, what we want to do is distribute this, so we'll have sine plus sine, and then I'm going to substitute what we know tan to equal sine over cosine. So then you're left with sine plus sine squared over cosine. And we'll multiply by cosine, so then you'll get cosine over cosine, so you'll get sine cosine over cosine plus sine squared over cosine. And what you're left with is, you could factor out a sine. So actually we could factor out on both of these, we could factor out a tangent, right? So sine squared is the same as saying sine times sine over cosine. So if you factor out a tangent, what we're going to be left with is tan. When I say we can factor out a tangent, what I really am saying here is we can, out of both of these, we can factor out a sine over cosine. So we're left with sine over cosine on the outside, times, and then cosine's left, and sine is left. Sine over cosine can then be reduced to, or changed to tan. And if we want it to completely match what we got in there, we could rearrange it to be sine plus cosine. So just remember, when you're doing these, take it one step at a time. Don't be afraid to look back at your identities, or to try to recall those. Remember all those the identities there. A lot of them you'll use, but you might have to solve it for something other than the way it's written. For instance, there were a few of them where we had secant squared minus 1 is equal to tan squared. So in this case, we were solving for tan. So there's different ways that you can do it, but really these are some of the big ones to remember. And best of luck on any future assessment you have on these. If you want to see me do more examples, by all means feel free to reach out to me. But good luck.